The air above the Australian grasslands is alive with motion, but there is a certain stillness in the way the brown falcon holds itself against the wind. Its wings, long and pointed, barely tremble in the shifting currents, the bird adjusting minutely with each gust. From a distance, the falcon appears suspended, as if the air itself has taken an interest in holding it there. Yet every feather is working, every twitch and ripple an unconscious calculation of lift, drag and balance. It is not merely flying, it is reading the sky. The Aboriginal peoples of Australia have long watched such movements with a quiet intensity. In the lore of certain regions, the sight of a brown falcon circling low or calling in a particular pattern is no coincidence. It is a sign, a warning from the aerial world that the land is about to change. A storm might be building beyond the horizon. A bushfire may be crawling closer, its smoke too faint for the human nose to catch, but already visible to eyes honed by predation. The falcon becomes more than a hunter in these moments. It becomes an emissary between realms, the stable ground beneath and the shifting, unpredictable sky above. Modern science lends weight to this ancient reading. Raptors, like the brown falcon, are exquisitely sensitive to atmospheric changes. Within their hollow bones lies a fine-tuned system for detecting air pressure shifts, enabling them to anticipate storms hours before the first cloud darkens the sun. Small adjustments in their wing-beat cadence can be a direct response to thermal currents cooling ahead of a front. In effect, they become barometers with talons. The falcon's vantage is not purely passive observation. From above, it sees not only prey, but also the movement of life across the land. Rodents abandoning low ground, wallabies altering their grazing routes, even insect swarms rising ahead of a change in wind, all of these register as shifts in the living map it memorizes daily. When it circles lower, when its calls take on a sharper cadence, it is often the culmination of dozens of such observations. A predator's survival depends on this synthesis of information, but for the initiated among humans, those same patterns can be read as a code for self-preservation. Close up, the brown falcon is not an imposing giant. It measures barely half a meter from beak to tail, its plumage a mix of warm earth tones streaked with darker bars, the perfect camouflage for both wooded edge and open field. But its eyes, large and forward-facing, are a study in precision. A falcon's vision is roughly 8 times sharper than that of a human. At 100 meters, it can discern the twitch of a mouse's ear in the grass or the shimmer of heat rising from a patch of bare earth. This ability is more than raw eyesight. It is the result of a retina so densely packed with photoreceptor cells that the bird can track the jerky, high-speed movements of insects or lizards that would appear as blurs to us. The falcon's life is a balance between patience and sudden violence. When hunting, it often hovers, a behavior known as kiting, keeping its head perfectly still while its wings and tail adjust in constant micro-movements. From this aerial tripod, it can launch without warning into a steep, controlled dive, talons extended. Those talons, curved and needle-sharp, are the tools of a predator evolved to seize prey mid-flight or pin it to the earth before it can escape. In rare cases, when humans venture too close to a nest, those same talons have been turned against us. The strike is not a random flurry, but a targeted blow, often aimed at the head or shoulders. Eye injuries from raptor swoops are not mere legend. They are recorded hazards for anyone unaware of their proximity to nesting grounds. In ecological terms, the brown falcon is not a specialist, but an opportunist. While other raptors may rely heavily on a single type of prey, the brown falcon adapts fluidly to whatever the environment offers. Insects in summer, rodents in drought, small reptiles during cooler months. Each is taken with equal skill. This adaptability is one of the reasons the species thrives across a range of habitats, from coastal plains to the sparse interior. But with opportunism comes a role as a regulator. By preying on species that would otherwise surge in number, the falcon helps maintain the equilibrium of its ecosystem. This balancing act extends beyond food chains. By moving across large territories, falcons indirectly track the health of the land. An abundance of grasshoppers may indicate a dry season's impact on plant cover. A spike in rodent activity may hint at stored seed supplies vulnerable to both pest outbreaks and fire. Observers of the falcon's flight patterns are, in a sense, reading a live summary of the ecosystem's condition. And yet, the brown falcon is not without its own vulnerabilities. Prolonged drought can thin its prey base, forcing it to range farther and expend more energy in the search. Bushfires, events it can sometimes warn of through its behavior, may also destroy its nesting sites. In some regions, falcons have been observed hunting near the edges of controlled burns, exploiting fleeing insects and small animals. This adaptive behavior, remarkable as it is, carries risk. A sudden wind shift can trap the bird in smoke or flame. From a human safety perspective, the brown falcon's dangers are rare but real. Direct physical harm most often comes from territorial defense. A swooping raptor, moving at speeds of 60 kilometers per hour and armed with talons designed to pierce through muscle, is not easily deflected. Even without physical contact, the surprise and confusion of such an attack can lead to secondary injuries. Falls from ladders, collisions, or dangerous stumbles in rough terrain. Indirectly, the bird can be a vector for disease. Contact with feathers, carcasses, or droppings can transmit salmonella and other pathogens, especially to those working in wildlife rehabilitation or falconry. Despite these hazards, the brown falcon remains a species whose presence can benefit human survival in subtle, indirect ways. In agricultural areas, they reduce pest populations that might otherwise devastate crops. In natural settings, they serve as early indicators of environmental disturbance. And in the Aboriginal tradition, they form part of an unbroken chain of observation, a living thread between generations that reads the language of the land through wing beats and shadow. To watch a brown falcon on a day when the air is heavy and still is to feel the weight of that language. It may rise higher, seeking distant thermals that no human can sense, or it may remain unnervingly low, its path looping tighter and tighter over the same patch of ground. On such days, elders would tell you to pay attention, not just to the bird, but to the silence of the insects, the sudden stillness of the grass, the way distant clouds gather in columns. Modern meteorology might later confirm that a storm was on its way, but to those who have long shared the land with the falcon, the message was already clear. The brown falcon is not a prophet. It cannot foresee the future in the mystical sense. But it is an interpreter of the present, a creature so finely attuned to its environment that its very movements become a kind of broadcast. For those who know how to watch, that broadcast is not merely a detail of the wild, it is a survival signal. To ignore it is to walk blindly into the path of forces far greater than oneself. To heed it is to remain in step with the rhythms of a land where danger and safety are often separated by the beat of a wing. The tide is low, and the reef lies exposed in a quiet stillness that belies the complexity of life within its boundaries. Pools of seawater remain trapped between corals and sand, their surfaces shimmering in the sharp Australian sunlight. A casual wader might see nothing but bare rock, a scatter of shells and rippling shadows, Yet beneath that thin veil of familiarity rests one of the most dangerous creatures on Earth, the stonefish. Here, evolution has written a different kind of predator, one that survives not through the speed of the hunt, but through the mastery of invisibility. Its body is a patchwork of mottled browns, reds and greys, textured with lumps and ridges that imitate coral growths and encrusting algae. Seen from above, it is indistinguishable from the reef itself, the perfect impersonation of inert stone. In this deception lies its greatest strength, and for the unwary human foot, its greatest threat. For thousands of years, coastal Aboriginal groups carried a quiet awareness of these hidden guardians of the shallows. In Dreamtime narratives, certain stretches of river or lagoon were marked as sacred or forbidden, not out of superstition alone, but because those waters were kept by beings whose sting was a punishment and a warning. Over generations, such stories evolved into a cultural map of danger zones where fishing or bathing was avoided entirely. Modern marine biology, without the mythic language, simply confirms that these are prime stonefish habitats, warm, shallow waters with sandy or rubble-strewn bottoms where camouflage offers near-perfect protection. To understand the danger of the stonefish, one must first understand its method. It is an ambush predator of exceptional patience. Unlike the active hunters of the reef, the darting trevally or the prowling moray, the stonefish does not waste energy on the chase. It settles into the sand or wedges between corals, allowing silt to drift over its back. Its dorsal spines, the instruments of its venom, lie flat and concealed. For hours it remains motionless, its eyes the only hint of awareness. Then, when a small fish or crustacean ventures within range, it launches forward with astonishing speed, so fast that the strike can be completed in less than 0.015 seconds, faster than the human eye can follow. The prey is swallowed whole before it even knows it has been targeted. This economy of movement is more than a hunting strategy. It is a survival adaptation in an ecosystem where food availability can be unpredictable. By minimizing movement, the stonefish reduces its energy expenditure and lowers the chance of detection by larger predators. Camouflage also works in both directions. Not only does it make the stonefish invisible to prey, it shields it from becoming prey itself. While few animals willingly tackle such a venomous adversary, some sharks and rays are capable of consuming them without apparent harm, their thick skins and feeding techniques neutralizing the spines. For humans, the danger lies not in any predatory intent. The stonefish does not hunt us, but in the overlap of habitats. Shallow coastal flats, estuary mouths, and reef fringes are areas where people often wade or swim. A stonefish buried under a thin layer of sand or pressed against a rock will not flee when approached. Its survival depends on remaining perfectly still, and it will do so even as a human foot descends upon it. When stepped on, the fish reacts instantly, locking its body and raising its dorsal spines like a spring-loaded trap. Each spine is connected to a venom gland at its base. When pressure is applied, the sharp spine punctures the skin and forces venom into the wound. This venom is not simply a chemical deterrent. It is a complex cocktail of neurotoxins, cytotoxins, and myotoxins designed to cause immediate, overwhelming pain and systemic shock. Victims often describe the sensation as a searing, spreading agony that radiates up the limb, accompanied by swelling, tissue death, and, in severe cases, paralysis or cardiac arrest. Without rapid medical treatment, particularly with the administration of antivenom, the consequences can be fatal. The venom's potency is a reflection of evolutionary necessity. In the predator-rich environment of coral reefs and coastal shallows, the stonefish's lack of mobility demands a defense that can stop an attacker instantly. Pain serves as both a deterrent and a teaching tool. Predators that survive an encounter rarely risk another. For humans, however, the lesson comes at an often agonizing cost. Even with treatment, victims may suffer long-term consequences. Nerve damage that leaves lingering numbness or hypersensitivity, chronic pain triggered by minor injuries, and in some cases, lasting muscle weakness. Secondary risks follow the initial injury. The puncture wounds from the spines are deep and often carry marine bacteria into the tissue. In warm, nutrient-rich tropical waters, such infections can spread quickly, complicating recovery. Certain species of Vibrio bacteria, common in marine environments, can cause severe tissue damage if untreated, sometimes requiring surgical intervention. For Aboriginal communities whose traditional fishing and foraging might bring them into contact with stonefish-rich areas, this knowledge translated into strict avoidance of certain waters during specific seasons. Stonefish also play a role in the ecological balance of their habitat, though it is a quiet one. By preying on small fish and invertebrates, they help regulate the population dynamics of the reef fringe. Their ambush strategy removes the unwary, shaping behaviors in prey species and perhaps indirectly influencing patterns of movement within the reef community. In this way, the stonefish exerts a subtle pressure on the ecosystem, its presence felt even if rarely seen. The adaptations that make the stonefish so formidable also reveal a sophisticated balance of form and function. Its skin is thick and leathery, resistant to abrasion from sand and rock. The irregular contours of its body disrupt its outline, making it blend seamlessly with the reef substrate. Its eyes, positioned high on the head, allow it to watch for both prey and predators without shifting its body. The mouth is cavernous and upturned, enabling a rapid suction strike that pulls prey in along with the surrounding water, minimizing the chance of escape. Unlike many fish, the stonefish is capable of surviving out of water for several hours, a useful adaptation for life interval zones where pools can dry unexpectedly. During these periods, it remains motionless, conserving energy and moisture until the tide returns. This resilience, coupled with its venom, makes it a creature well equipped for the unpredictable rhythms of the intertidal world. In the modern era, knowledge of the stonefish is a matter of both science and public safety. Beach safety campaigns in northern Australia warn swimmers and divers to wear protective footwear and to shuffle their feet when wading, a movement that disturbs the sand and alerts hidden fish before contact is made. Divers are trained to scan the seabed for the telltale outline of a stonefish, though even experts can be fooled by its camouflage. Medical protocols stress the urgency of heat treatment for venom pain, as the toxins are heat-sensitive and can be partially neutralized by immersion of the affected limb in hot water. Yet even with these precautions, the stonefish retains an aura of latent danger. It is a reminder that in the ocean, not all threats announce themselves with teeth or speed. Some lie in wait, embedded in the landscape itself, their presence known only to those who have learned to read the subtler signs. For Aboriginal elders, the knowledge passed down through stories was as much about respect as it was about survival. The forbidden waters were not simply dangerous, they were home to life that demanded acknowledgement of its place in the world's design. To walk barefoot in such a place without awareness is to step into a silent negotiation with a master of patience and disguise. In that instant, The stillness of the reef gives way to a burst of pain, a surge of biology honed over millions of years. The stonefish remains behind, unmoved, its camouflage undisturbed, ready for the next unwary trespasser. In the end, it is not malice that makes the stonefish deadly, but the precision of its design, a living paradox of stillness and lethality, carved into the very shape of the reef. The mangrove estuary at dawn is a place of deceptive peace. The air is heavy with the scent of brine and silt, the surface of the water glassy and unbroken, except for the occasional ring of an insect landing. Beneath this stillness lies a complexity of life that few will ever witness, and a predator that has perfected the art of invisibility within it. The saltwater crocodile, largest of all living reptiles, has been patrolling these waterways since long before the first humans walked these shores. In Aboriginal tradition, certain river crossings and estuary mouths were, and in many places still are, avoided, spoken of in terms of spirits or ancestral beings. These are the territories of the crocodile, beings that in Dreamtime narratives are guardians of the boundaries between worlds, the safe and the dangerous, the known and the unknowable. It was a cultural boundary as much as a physical one, a warning encoded in story and ritual. To cross without respect was to risk vanishing into the water forever. Modern science offers its own confirmation. These sacred zones often overlap perfectly with prime crocodile ambush sites, narrow crossings, deep channels, and shaded banks where visibility is low and escape routes for prey are limited. The saltwater crocodile is not a wanderer without reason. It is a master of territorial control. Large males may claim stretches of river spanning dozens of kilometers, defending them with displays of sheer force. Jaw claps that echo through the mangroves, violent thrashes of the tail, or, when challenged, explosive confrontations that leave the water roiling with blood and bubbles. Such dominance is not just posturing. A mature crocodile can exceed 6 meters in length and weigh more than a ton, an apex predator whose physical power is matched by its strategic patience. Hunting begins with absence, or rather, the illusion of it. The crocodile's body, flattened and low, merges seamlessly with the water's surface. Only the eyes and nostrils break the line, both set high on the skull so the rest of the animal remains submerged. The skin is a mosaic of ridged scales, each dotted with integumentary sensory organs, tiny, dome-shaped structures capable of detecting the faintest disturbance in the water. These sensors allow the crocodile to register a fish's tail flick or the vibration of a wading bird's step with astonishing accuracy. Even at night, when visibility is poor, this sensory network makes the crocodile's perception of its environmental most omniscient within its immediate range. When the strike comes, it is a release of coiled energy that has been building in utter stillness. The crocodile surges forward in an explosion of water, jaws opening wide to reveal conical teeth built not for slicing, but for gripping. The bite force, measured at over 3,000 pounds per square inch, is the most powerful of any living animal, capable of crushing turtle shells or bone with ease. Once the jaws close, escape is nearly impossible. The crocodile's teeth interlock to hold prey in place, while the animal's neck muscles drive it into a violent twisting maneuver known as the death roll. This spin, powered by the tail and entire torso, disorients the prey and tears flesh from bone. For humans, the danger lies in the crocodile's ability to launch this attack from complete concealment and at astonishing speed. From a standstill, a large male can lunge several meters in less than a second, propelled by the muscular sweep of its tail. Many victims never see the animal before it strikes. Those who survive the initial capture may still be dragged underwater, where the crocodile holds them until their struggles cease. The murky water of estuaries works in the predator's favor, hiding both its approach and its final disappearance. While its hunting style is brutal, the crocodile's survival strategy is as much about energy conservation as it is about force. As a reptile, it is ectothermic, dependent on external heat sources to regulate body temperature. This allows it to go for long periods without feeding. A large adult can survive months on a single substantial meal. During cooler parts of the day, crocodiles haul out onto mudbanks to bask, absorbing solar heat to fuel their metabolism. When temperatures rise, they slide back into the water, using the thermal stability of the river to avoid overheating. These cycles of movement are not random, but finely tuned to seasonal rhythms, tide patterns, and even lunar cycles, all of which influence the behavior of their prey. Reproduction introduces another dimension to their territorial behavior. Females build nests of vegetation and mud along riverbanks during the wet season, taking advantage of the heat generated by decomposing plant matter to incubate their eggs. The location of these nests is chosen with care, high enough to avoid flooding, yet close enough to the water for the hatchlings to reach safety. In a surprising display of parental investment, the female guards her nest and, when the time comes, carries the hatchlings gently in her mouth to the water. Yet even in this act of care, danger lurks. Nearby males will not hesitate to prey upon unprotected young, and territorial disputes during the breeding season can be especially violent. The saltwater crocodile's dominance extends beyond the confines of a single river. They are powerful swimmers, capable of crossing open sea to reach distant islands or new territories. Tagged individuals have been recorded traveling hundreds of kilometers along coastlines, riding tidal currents with minimal effort. This mobility makes them unpredictable in their range and reinforces the Aboriginal view of certain waters as inherently dangerous, a place where the guardian might appear without warning. In the context of human safety, the crocodile's presence demands vigilance. Fatal attacks are rare relative to the animal's range, but when they occur, they are often sudden and without opportunity for defense. Boats, too, are not immune. There are documented cases of crocodiles ramming or attempting to climb into small vessels that stray too close to their territory. Their territorial aggression is not indiscriminate violence, but an evolved strategy to protect prime hunting and breeding grounds from competitors. Unfortunately, humans are not exempt from being perceived as intruders. The ecological role of the saltwater crocodile is one of regulation and recycling. By preying on the weak, the sick, or the unwary, they help maintain healthy populations of fish, birds, and mammals within their range. Their kills provide food for scavengers, from waterbirds to crabs, creating a ripple effect of energy transfer throughout the food web. Even their nesting activities shape the landscape. The disturbance of soil and vegetation along banks influences plant succession and sediment dynamics. For all their power, saltwater crocodiles are not invulnerable. Habitat destruction, illegal hunting, and climate change, particularly sea level rise and altered river flow, threaten nesting sites and prey availability. In some regions, protection measures have allowed populations to rebound from near collapse in the mid-20th century, but this recovery has also brought them into closer contact with expanding human settlements. Coexistence requires not just legislation, but a cultural respect for boundaries, something Aboriginal traditions have practiced for millennia. Standing at the edge of a tidal channel, it is easy to be lulled by the silence, to mistake absence for safety. Yet the water here is opaque, concealing more than just fish and debris. Beneath its surface lies a predator that has outlasted ice ages, sea level shifts, and the rise and fall of civilizations. Its methods have not changed because they do not need to. The river, the tide, and the crocodile are part of the same enduring system, one in which the unwary step is the last. In the ancient calculus of survival, the saltwater crocodile is both warning and consequence, a living embodiment of the rule that some places are crossed only with permission and sometimes not at all. To understand this is to respect the boundaries it enforces, boundaries that are as much about the rhythm of life in the water as they are about the unblinking eyes that watch from just beneath its surface. The heat on the plains does not arrive suddenly. It builds in long, slow increments, the kind that pull moisture from the soil and set the air shimmering in invisible waves. Grasslands that were once green and supple take on a pale, straw-colored hue, and the wind, when it comes, carries dust rather than cool relief. It is in these moments, well before the human eye would register real danger, that the kangaroo mobs begin to move. For Aboriginal peoples whose survival depended on intimate familiarity with the land, such movements were far from random. A sudden absence of kangaroos from a known feeding ground was more than a quirk of wildlife behavior. It was a sign. In the cultural map of Dreamtime narratives, this absence often marked places where the land was spiritually wrong, where ancestors had laid warnings in story form. These might be areas about to be swept by bushfire, river flood, or the slow catastrophe of drought. Over generations, the pattern was clear. Where kangaroos refused to graze, people were wise to follow. From a biological perspective, this is not mysticism, but sensitivity. Kangaroos are tuned to environmental cues with a precision born of necessity. In a continent where resources are scattered and conditions swing from abundance to scarcity with little warning, survival depends on the ability to detect subtle changes in the ecosystem. The scent of smoke on the wind, almost imperceptible shifts in plant chemistry, or the distant thud of hoofed predators, all can trigger a change in movement. Their large mobile ears swivel independently, scanning in different directions for sound. Their nostrils flare to test the air, the moisture-sensitive tissue inside able to detect changes in humidity and temperature that precede storms or the dry winds of a fire front. The kangaroo's body is an instrument built for distance and efficiency. The most striking adaptation is, of course, the hind legs, long muscular levers powered by massive tendons that store and release energy with each hop. This tendon-driven locomotion is not just a matter of speed, it is astonishingly economical. At moderate pace, a kangaroo's oxygen consumption barely increases compared to standing still, allowing them to travel long distances without exhausting their energy reserves. In migration mode, a mob can cover 25 kilometers in a single night, often arriving in fresh feeding grounds before dawn. The social structure of a kangaroo mob adds another layer to their role as ground messengers. These groups are loosely organized with individuals coming and going, but the largest males, dominant boomers, often act as sentinels. While the rest of the mob grazes, one or more will stand tall, scanning the horizon. This is not just vigilance against predators like dingoes or wedge-tailed eagles. It is a constant assessment of the landscape itself. When a sentinel moves on, others take notice. This chain reaction can set an entire mob into motion, their synchronized departure an unspoken message to any observer that something is changing. Kangaroos are not without their capacity for violence, and their relationship with humans has always balanced wariness with the potential for sudden aggression. A large male, standing well over 2 meters when upright, can weigh more than 90 kilograms. In combat, they rear back on their muscular tails to deliver double-footed kicks aimed with precision. The claws on those hind feet are capable of tearing deep wounds, enough in some cases to disembowel an opponent. Forelimb claws, though smaller, are sharp and used in grappling, where a kangaroo can hold and rake simultaneously. While such confrontations are rare in the wild, generally occurring only when a male feels cornered or is competing for dominance, human encounters can turn dangerous when territory, food or water are contested. Kangaroos raised in captivity or too accustomed to human presence may lose their natural caution, increasing the risk of aggressive interaction. Even without aggression, their sheer size and unpredictability can make close encounters hazardous. Another danger, less personal but more widespread, comes in the form of collision. Kangaroos are crepuscular, most active at dawn and dusk when low light reduces human visibility. Their tendency to cross open ground in large groups at speed makes them a frequent cause of road accidents in rural Australia. A collision with a large kangaroo can be catastrophic for both animal and driver, especially at highway speeds. Their unpredictable change of direction mid-hop makes avoidance difficult, and the instinct to flee toward open ground often brings them directly into the path of vehicles. Ecologically, kangaroos are grazers whose feeding patterns influence plant community dynamics. By selectively cropping grasses and herbs, they help prevent overgrowth that could fuel intense bushfires, while their movement across large territories aids in seed dispersal. In drought years, their ability to locate and exploit remaining patches of green can lead other herbivores and even livestock to the same resources. This role as both competitor and guide adds complexity to their relationship with human land use, especially in agricultural zones. Thermoregulation is another area where kangaroos reveal their evolutionary mastery of Australia's extremes. Unable to sweat over most of their body, they instead lick their forearms where a dense network of blood vessels runs close to the skin. The evaporation cools the blood before it circulates through the rest of the body. In high heat, they may seek shade and reduce activity, but when mobility is required, such as during long migrations to avoid fire or drought, they adjust travel times to cooler night hours, conserving water and energy simultaneously. Interestingly, their movement ahead of environmental threats is not always a response to immediate danger. Studies have shown kangaroos sometimes relocate days or even weeks before conditions visibly deteriorate. This suggests they may be responding to changes in plant moisture content, airborne chemical signals from stressed vegetation, or even barometric pressure shifts preceding storms. These cues are often too subtle for humans to notice without instruments, reinforcing their value as early warning indicators in the Aboriginal observational system. Predator-prey dynamics play a subtler role in shaping kangaroo behavior. Dingoes are their primary natural predator on the mainland, and the presence of a hunting pack can cause a mob to vacate an area well in advance of an attack. The interplay between these species is an ongoing contest of endurance and vigilance, with kangaroos relying on their superior long-distance travel to outlast and outpace pursuit. Raptors may threaten juveniles, and pythons in some regions will take young at the edge of waterholes, but for adults, the chief threats are terrestrial and increasingly human. In the wider ecological web, kangaroos are both shapers and shaped. Their grazing influences the growth of certain plant species, which in turn affects insect populations and the birds and reptiles that feed on them. Their droppings fertilize the soil, supporting microfaunal communities that enrich the land. When they abandon an area, the sudden absence of these contributions can be felt throughout the local ecosystem, further marking their departure as a signal of change. To stand in the half-light of an early morning and watch a mob in motion is to see the landscape interpreted in real time. They move with a fluid rhythm, ears twitching, heads rising and lowering as if in unison, the sound of their hops a muted drumming against the earth. To an untrained eye, it might appear as simple foraging behavior. To those who have learned to read the land, it is information, as clear as a weather forecast, as urgent as a warning siren. The kangaroo's message is not broadcast in alarm calls or dramatic displays, but in the quiet decision to leave. In this choice lies a knowledge older than settlement and science alike, that survival often depends on moving before the danger is visible, trusting the signs that the body, and the body of the mob, has already read. In the filtered light beneath the eucalypt canopy, movement is subtle. A flicker of leaves from a passing breeze, the shifting shadow of a bird overhead, the tremor of an insect on the forest floor. Somewhere within that patchwork of motionless debris, a shape rests along the warm length of a fallen log. To the untrained eye, it might be a thick root, its surface mottled with patches of lichen and dusted with the pale brown of leaf litter. But the root is breathing, each rise and fall so slow it seems to belong more to the forest itself than to a living creature. This is the python, a predator without the need for haste, and in some Aboriginal traditions, a sentinel whose absence from a place is warning enough to keep away. For countless generations, Dreamtime stories have encoded this observation. Certain grounds where pythons are never seen are places where danger resides. Whether this danger was ecological, spiritual, or practical in nature, the principle held, country where the great snakes will not go, is country worth avoiding. From the standpoint of modern ecology, the reasons for such avoidance may be tied to soil chemistry that limits burrowing prey, scents carried on the wind from large predators, or a simple absence of shelter that leaves the snake too exposed. But the result is the same. Pythons, with their acute environmental awareness, are both inhabitants and interpreters of the land. Unlike the crocodile, whose presence is often betrayed by ripples and sudden violence, the python moves through the landscape in a near-perfect silence. It is not a hunter built for speed. It is built for precision, for being in exactly the right place at exactly the right time. Its muscles run the length of its body in a coordinated series of bands, each capable of shifting the snake forward in graceful, almost liquid undulations. These muscles are both engine and weapon. When a target comes within range, the python strikes, seizing it with jaws lined by dozens of sharp, backward-curving teeth. The motion that follows is as much instinct as it is strategy. The body loops around the prey, coils tightening with each exhalation until the victim can no longer draw breath. Constriction is not an act of crushing bones, as is often believed, but of steadily halting circulation and respiration until the prey succumbs. For smaller animals, the process is quick. For larger ones, it may take several minutes. The python's capacity for patience extends into feeding itself. Its lower jaw is connected by elastic ligaments, allowing it to swallow prey several times wider than its own head. The act of swallowing is methodical, each side of the jaw working independently in a ratcheting motion, muscles of the throat massaging the prey down toward the stomach. Once inside, powerful acids and digestive enzymes break down not just flesh but bone, leaving little behind except indigestible fragments. After such a meal, the snake may not need to hunt again for weeks or even months, depending on temperature and prey size. Pythons are sensitive to their environment in ways that are invisible to human senses. Along their lips run heat-sensitive pits, capable of detecting the infrared radiation emitted by warm-blooded animals. Even in total darkness, these pits allow the snake to see the heat signature of a bird roosting on a branch or a small mammal moving in the leaf litter. This adaptation is particularly effective during the cooler night hours, when the ambient temperature drops and warm-bodied prey stands out against the cooler background of the landscape. Their movements are guided by a combination of scent, touch, and thermal perception. The tongue flickers constantly, collecting microscopic particles from the air and ground, delivering them to the Jacobson's organ in the roof of the mouth for analysis. Through this chemical map, a python can determine not only the species and size of a potential prey animal, but also its direction and how recently it passed by. This sensory web makes them exceptional trackers, though they do not pursue prey in the relentless way mammals might. Instead, they use the information to position themselves in high-probability hunting zones, along animal trails, near waterholes, or within the branches that overhang feeding sites. Despite their methodical nature, pythons are capable of surprising bursts of speed when necessary. A strike from a coiled position is a sudden release of stored muscular tension, the head shooting forward with enough force to anchor those recurved teeth deep into the prey. For humans, a bite delivered in defense rather than predation can be shocking in its intensity. While non-venomous, the teeth can cause deep lacerations, and their backward curve means that pulling away quickly can tear flesh further. Any wound from a wild python also carries a risk of infection, particularly from bacteria such as Salmonella, which can be present on their skin and in their digestive system. The dangers pythons pose to humans are, in truth, more a matter of proximity and size than of intent. A large individual, over 4 meters in length, is capable of overpowering a child or small adult, though such incidents are exceedingly rare in Australia. More common are defensive bites, when a python is startled at close range, in a shed, beneath a veranda, or coiled among branches during a fruit harvest. The risk is not from venom, but from the sheer mechanical damage those jaws and teeth can inflict, followed by the potential for secondary infection. In the ecosystem, pythons fill a critical niche. They control populations of rodents, birds, and other small animals that could otherwise reach destructive numbers. By preying on a wide range of species, they help maintain balance among competitors and prevent any one population from overwhelming the resources of a given habitat. In some areas, their predation on invasive species, such as black rats, indirectly benefits native plants and the animals that depend on them. Their avoidance of certain areas, the very behavior noted in Dreamtime warnings, has its own ecological implications. The absence of pythons can signal a scarcity of prey or the dominance of larger predators such as goannas or feral cats. In some cases, it may be linked to soil or vegetation changes that reduce cover, making ambush hunting less effective. This avoidance becomes part of the broader web of environmental indicators. Just as the absence of kangaroos can hint at coming drought or fire, so too can the absence of pythons point to more localized imbalances or hidden dangers. Thermoregulation shapes their daily rhythms. Being ectothermic, pythons rely on external heat to maintain body function. They bask in the morning sun to raise their body temperature, often draping themselves over exposed logs or rocks. As the day heats, they retreat into shade, burrows, or the cool interiors of hollow trees. In cooler months, they may reduce activity dramatically, entering a state of torpor in which their metabolic rate slows and hunting is minimal. These cycles not only conserve energy, but also align the snake's peak activity with the times when prey is most accessible. Breeding brings its own remarkable behavior. Unlike most reptiles, some pythons exhibit maternal care during incubation. The female coils around her clutch, protecting it from predators and even generating heat through shivering thermogenesis, a series of muscle contractions that raise her body temperature and keep the eggs within an optimal range. This investment of energy is significant, and during this time the female may not eat, relying entirely on stored reserves until the hatchlings emerge. Once they do, they are independent, equipped with the instincts they will need to survive in a world where every movement and choice can mean the difference between life and death. For those who walk the same land, reading the python's patterns is as much about safety as it is about understanding the health of the ecosystem. In the Aboriginal way of knowing, the presence or absence of such a predator is never random. It is part of a larger conversation the land is having with those who know how to listen. To ignore the absence of the silent boundary keeper is to risk stepping into places where the balance is already broken, whether by scarcity, hidden predators, or forces unseen. Seen this way, the python is not simply a hunter in the understory. It is a moving measure of the land's integrity, a gauge of its capacity to sustain life. Its coils are both weapon and shelter, its presence both reassurance and warning. And when it chooses not to be somewhere, that absence can speak volumes. In a country where survival often depends on reading the subtlest signs, that silence may be the most important message of all. At first light, Australia is a continent of contrasts. The pale dawn spills across inland plains, catches the jagged silhouettes of mangroves along tidal rivers, and glints on the still surface of shallow reef flats. In the cool air before the day's heat takes hold, life is already in motion, but not all of it is visible. Some of it moves in shadows, some lies perfectly still, and some drifts silently high above. Across these landscapes, from the saltwater channels to the inland grasslands, a web of life carries with it more than just the story of predator and prey. It carries the knowledge of place, an ancient code that, if read correctly, can mean the difference between safety and catastrophe. For the Aboriginal peoples who have walked this land for tens of thousands of years, these codes were not abstract theories. They were embedded in story, song, and ceremony. To see the sudden circling of a brown falcon in an unexpected place was to know that the sky itself was speaking, that winds were shifting, that pressure was falling, that change was coming. Long before meteorology gave names to these patterns, the falcon's behavior served as an aerial forecast, its movements mapping the unseen currents of the atmosphere. Yet that same bird, so attuned to the land's rhythms, carried its own risks. Talons capable of opening flesh in an instant, a beak evolved to shear meat, and the ever-present possibility of disease passed invisibly through contact. Below the waterline, the reef flats and estuary mouths held their own silent enforcers. The stonefish did not announce itself with movement or color. It simply existed as part of the sea floor, a masterwork of camouflage whose presence was revealed only to those who had learned where not to step. In Dreamtime traditions, these forbidden waters were not arbitrary. They were mapped precisely to the habitats where the fish's venomous spines waited. That venom, an intricate blend of toxins, could halt a human life within hours, its purpose honed not for attack but for absolute deterrence. The danger was invisible, and therein lay its power. In the estuarine heartlands, the saltwater crocodile stood, or rather drifted, as the river's uncompromising sentinel. These were the sacred crossings, the places where survival hinged on knowing who controlled the water. The crocodile's dominance was enforced with a bite that could pulverize bone, a strike launched from perfect stillness, and a territorial memory that extended across kilometers of tidal channels. To cross into its domain uninvited was to gamble against an apex predator that had survived virtually unchanged since the age of dinosaurs. It was not a question of if it could kill, but whether it chose to. On the inland plains, danger moved differently. It was not the presence of a predator, but the absence of the kangaroo that spoke volumes. A feeding ground emptied overnight could mean the grass ahead was withering from drought, that a fire line was moving unseen, or that human disturbance had shifted the balance. The kangaroo's mobility, its tendon-driven leaps, its long-distance endurance, allowed it to move early, well before conditions became visibly hostile. Yet its presence near people carried risks of its own, the sheer power of a defensive kick, the rake of four-limb claws, and the sudden, often lethal collisions on rural roads when their flight instincts met human speed. And in the shaded understories and sunlit edges of forest and savanna, the python held its quiet dominion. Where it did not go, there was reason. Its absence from a place could mark the land as inhospitable, whether through lack of prey, the dominance of other predators, or environmental instability. Where it was present, it hunted with absolute efficiency, heat-sensing pits mapping warm-blooded prey, coils delivering the slow certainty of constriction, and recurved teeth anchoring the kill. For humans, the danger came less from deliberate attack than from proximity. A defensive strike, a deep bite, the unseen transfer of pathogens. Individually, these animals tell stories about adaptation, about evolutionary design shaped over millions of years to meet the challenges of one of the most demanding continents on Earth. But together, they form something more, an interlocking network of signs. The Aboriginal Warning System Theory proposes that these signs are not coincidence, but the result of generations of observation distilled into cultural memory. Each species, in its own way, offers an early signal of environmental change or immediate risk. The falcon reads the air, the stonefish guards the shallows, the crocodile controls the crossings, the kangaroo gauges the safety of the plains, the python marks the health of the ground itself. For the uninitiated, these patterns remain invisible. A bird's low circle might be dismissed as random flight. A stretch of empty grazing land could be mistaken for chance. A still river might seem safe simply because its surface is calm. But to those who have learned the code, the land is a constant conversation, one in which every movement, absence, and behavior carries meaning. The warning may not come in human language, but it is precise, and it is often given well before the danger arrives. These creatures are not allies in the human sense. Each is entirely committed to its own survival, and contact with any one of them carries risks that can be sudden, severe, and irreversible. They are capable of inflicting wounds that maim or kill. The falcon's talons, the stonefish's venom, the crocodile's crushing bite, the kangaroo's double-footed strike, the python's coils and teeth. And yet, in their movements and choices, they have also acted as unwilling sentinels, their behaviors offering humans a way to navigate a land where hazards often reveal themselves too late for direct perception. In modern terms, the survival value of this code is obvious. By interpreting animal behavior as environmental data, humans gain a biological early warning system. But in the context of the Dreamtime, it is also about relationship, the understanding that humans are part of the same system, subject to the same rules, and dependent on the same cues as every other living thing. Respecting these boundaries was not simply a matter of avoiding injury, it was a way of living within the limits set by the land itself. Australia remains a place where those limits can be unforgiving. The environment can change with startling speed, and its dangers are not always where they seem. The animals that embody the Aboriginal Warning System Theory remind us that survival here has never been about control. It has always been about awareness, the constant reading of signs, the willingness to act on them without waiting for proof, and the humility to understand that the land's oldest guardians do not owe us their warnings. To walk this country without that awareness is to move blind through a place that is speaking all the time. To walk with it is to hear the ancient code still alive in the falcon's flight, the crocodile's stillness, the kangaroo's absence, the python's chosen ground, and the silent shape of the stonefish resting on the reef. The code does not promise safety, but it gives something better, the knowledge of where to tread and where not to in a land that remembers every step.